Hello friends, welcome to Electronic Circuit Hub. So today we are going to learn about the isolated MOSFET gate driver by using pulse transformer design. Okay, so we will design isolated MOSFET gate driver by using pulse transformer, right? We will understand how this circuit works, and I'll also run the simulation and I'll show you the waveform, what is the input signal, how you can drive this M2 MOSFET by using your microcontroller, what is the signal at transformer, pulse transformer primary, what is the signal at pulse transformer secondary, why do we need this diode here D2, and this is your gate, this is your main MOSFET which you want to drive and you want to isolate, right? You want to isolate. So this is very interesting. And what is the load signal here? Okay, so let us understand first how this circuit works. Okay, and this is very important topic. Okay, we need to understand how you can design isolated MOSFET gate driver. Okay, if you design isolated MOSFET gate driver, you can drive your MOSFET either high side or low side. So in this application I am driving my MOSFET in low side. You can see, okay, MOSFET M1 is driven in low side. It's a low side MOSFET gate driver. Okay, so you can see here, this is V2, that is DC. If I right click on V2, it's 5 volt pure DC, and you can see then I have the LP. LP stands for primary inductance. Okay, so this is the primary inductance and that is 100 microhenry. And you can see, since we are switching the inductance or coupled inductor, you can see this is coupled inductor or transformer, pulse transformer, it generates the pulse output, right? So since we are switching the inductor, so we need to discharge this inductor during off time. So I connected one diode D1, and you can see this is MOSFET AO6408 N channel MOSFET, and this MOSFET gate I'm going to drive using microcontroller. Let us say this is your microcontroller PWM signal. Okay, this is your microcontroller PWM signal, and the amplitude of this on time is 5 volt, and you can see the frequency is around 2 kilohertz. That is, on time is 250 millisecond and off time is 500 millisecond. Okay, so our objective here is what I want to do here. So you need to understand this. So I have only the 5 volt signal. Okay, I have only the 5 volt signal here, and I have the PWM from the microcontroller, so I can drive this transformer. So since this is low side, okay, this is your microcontroller side and you have the low voltage signal, and but what you need to do is here, you need to drive your low side MOSFET by using 15 volt. So you have here 5 volt, right? You have here 5 volt, and you want to drive your MOSFET M1 by using 15 volt. Let us say 15 volt or 12 volt. Okay, let us consider for now 12 volt. So what you need to do is here, you need to amplify the input signal. Okay, you need to step up the input signal. That means if you have 5 volt at input and you want to have 12 volt at output, that means by using this coupled inductor or transformer or pulse transformer, you are stepping up the voltage here. Okay, so your input is 5 volt only, and your output of this transformer is, let us say, 12 volt, and by using that 12 volt you are driving your low side MOSFET. Okay, you are driving your MOSFET, and that drives your load R2. Okay, so here you can see this load is being driven by 24 volt. Okay, this is being driven by 24 volt in my application, but since this is isolated circuit, you can apply here high voltage. but make sure that you need to select the MOSFET M1 accordingly. Let us say if you want to apply here 240 volt, so you need to select the MOSFET accordingly, right? All right. So you can see this is coupled inductor and the inductance value is 100 micro Henry, and at the secondary side the inductance value is 900 microhenry. So if you want to calculate the turns ratio, so how will you calculate? It is square root of LP divided by LS, 100 divided by 900. So you can see you have 1 turns in primary. That means if you have 1 volt at primary, it will generate 3 volt at secondary. Since you have 5 volt at primary, it should generate 5 3s are 15 volt at here secondary. Okay, and this is coupling factor, right? K is coupling factor. So I define coupling between primary and secondary is very tight, that is 1. It is practically it is not possible. For the simulation purpose I kept it 1. So this is coupling between primary and secondary is 1. Now you will have here the 15 volt which is peak to peak. That means you will get here positive polarity voltage as well as negative polarity voltage. So to have, since we will drive our MOSFET with the positive voltage signal amplitude from 0 to 12 volt, I have connected this diode and this drives the gate of the MOSFET. And you can see R3 and R4, I have pulled down the gate of this MOSFET, and it also helps to discharge the MOSFET gate capacitance. If you want to drive it in a very high frequency, you need to have gate driver here, some other gate driver, as well as you need to have some good gate discharge technique. Okay, now this is MOSFET M1 FDMC8462, and you can see here I'm driving my load with 24 volt. So hope that is clear. Now let me run the simulation and let me show you the waveform. So you can see here this is pure 5 volt, that means it is DC, and you can see here my PWM. Okay, so let me show you. This is amplitude of this PWM is 0 to 5. Okay, you can see 0 here and 5 here, and let me, maybe I can show you the frequency of my signal. So you can see here it's 1.995, that is very close to 2 kilohertz. Okay, now this is our gate signal which drives, this is our gate signal here which drives the gate M2. You can see this is 0 to 5 volt, and you can see the voltage at drain of M2, and you can see it's look like from here like 0.7 volt to its 9 volt around. Okay, now let me show you the output of this here at before the diode D2. So let me show you here what is the output. So you can see it varying from around -12 -13 volt to here you can see it's a 12.6 volt. So you can see here both positive polarity and negative polarity. That means you have to have here peak to peak voltage. Since I want here the voltage between MOSFET gate to source is to be 0 to 12 volt, so that is why I connected this diode. And let me show you now the voltage at this point, and you can see the voltage at this point MOSFET gate to source is 0. You can see 0, and here you can see 12.5 volt. So that is how your MOSFET, that is how you are driving your MOSFET. Your input signal is only 5 volt, but your MOSFET gate to source voltage you are getting here is now 12.5 volt. And let me show you your load. So you can see your driving voltage is 24 volt and your load is 24 ohm. So it should have the current flowing through this resistor R2 is given by 1 amperes. So let me show you here. So you can see the current flowing through your resistance, your load is 0 to 1 ampere. Okay, so you can, so you now know how will you drive, how will you design a isolated MOSFET gate driver